I want to start today with an excellent book. It's this one. It is Mathematical Analysis by Apostel. A modern approach to advanced calculus. So, yeah, it's an excellent book because I think it's the book is a bit dry. Like you don't really want to study for it. Like linearly, and you don't only want this to be the only book you study, but it does contain a lot of results that you don't find in any other book, like what to do with summation. With summations you don't really find it in many other places. So it starts off with the real and complex number system, basic notions of set theory, elements of point set topology theory, the limit concept and continuity, differentiation of function of one real variable, differentiation of function of several variables, application of partial differentiation, function of bounded variation, rectifiable curves and connected sets, theory of Riemann-Stieltjes integrations, then multiple integrals and line integrals, vector analysis, infinite series and infinite products, sequence of functions, improper Riemann-Stieltjes integrals, and then Fourier series and Fourier integrals, and Cauchy's theorem and the residue calculus. So yeah, very comprehensive book, very good book. The exercises are rather difficult. Yeah, and I guess Apostel is a number theorist, I think. And I think it kind of shows in his exercises in what he, what he likes. So yeah, definitely a book I would recommend to people who want a reference book. Really, I think it's absolutely excellent as a reference book, and in like. When can you invert a power series? What do coefficients look like? You won't find it in many places, but this book does it. So yeah. Next here we have Numerical Recipes: The Art of Scientific Computing by Press, Tucholsky, Vetterling, and Flannery. So basically, it's a book with algorithms on how to compute things. And it's a very thick book. So it starts with linear algebraic equations, where you have the Gauss-Jordan methods, the LU decomposition, QR decomposition, and so on and so on. Interpolation, extrapolation, integration of functions, evaluation of functions, special functions, random numbers, sorting and selection, root finding and nonlinear set of equations, minimization and maximization of functions, eigensystems, fast Fourier transform, Fourier and spectral applications, statistical description of data, modeling of data, classification, inference, integration of ordinary differential equations, 2 points boundary value problem, integral equation and inverse theory, partial differential equations, computational geometry, and less numerical algorithms. So yeah, thousands of pages on all kinds of algorithms, and they're all coded in C++. So yeah, it's absolutely brilliant book. Definitely recommend this one if you want to code something, and yeah, it's absolutely excellent. Next comes a book that I really want to do with Crimson, actually. So here we have Complex Algebraic Curves by Kirwan. So it starts with some introduction and background, where they introduce the Nullstellensatz, foundations, algebraic properties, topological properties, Riemann surfaces, differentials and Riemann surfaces, singular curves. So yeah, it's all about curves in complex spaces. It's kind of a sequel to Garrity. this is algebraic geometry, but it doesn't go into schemes, even though later on you can go into schemes, definitely. I think the book is really nicely written. I think I really like this book a lot, and the exercises can be fairly difficult actually. So yeah, you see it's very topological too, but the fun topology, not the point set topology for Crimson. And yeah, it does a lot of very neat algebraic geometry things, while I guess not going into abstract stuff too much. So yeah, I do recommend this one. Next up we have Measure Theory and Fine Properties of Functions by Evans and Gariepi. So it's basically first start with general measure theory, Hausdorff measure, area and co-area formulas. Then we have Sobolev functions, BV function instead of finite parameter, and then differentiability and approximation by C1 function. A very advanced measure theory book. Yeah, it's rather difficult, but yeah, I'm not sure if anybody on the server is really into measure theory that much, but this would be a good sequel to like an ordinary measure theory book, I guess. Next we have a book on general relativity by Woodhouse. This is actually a sequel of his similar book on special relativity. So it starts off with Newtonian gravity, inertial coordinates and tensors, energy momentum tensors, curved space-time. Then it goes into tensor calculus, Einstein's equations, and spherical symmetry, orbits in Schwarzschild space-time, black holes, rotating bodies, gravitational waves, redshift, and horizons. So yeah, a pretty short book on general relativity. It's more for a mathematician than for a physicist, I guess. So expect a lot of mathematical theorems and a mathematical style. While I guess the physics is a bit lacking in this book. Next we have Intuitionistic Set Theory by Bell. It is set theory without the excluded middle. So it starts with intuitionistic Zermelo set theory, natural numbers and finite sets, the real numbers, intuitionistic Zermelo-Fraenkel set theory, and frame-valued models. And then the appendix on hating algebras and frames. So yeah, a pretty short book on set theory done intuitionistically, without excluded middle, without axiom of choice too. So yeah, kind of the stuff I like a lot. But I guess if you're really into this, you got Topos theory too now to look at, and not necessarily this. Next, you have an introduction to applied multivariate analysis with R. So it's a multivariate book, statistics. So we have multivariate data and multivariate analysis, looking at multivariate data visualization, principal components analysis, multidimensional scaling, cluster analysis, confirmatory factor analysis and structural equation models, and then finally the analysis of repeated measures data. So it's basically how to do it in R and how to interpret your results. It isn't like anything rigorous or something, or even remotely rigorous, but it just shows you how to do it in R and how to interpret things, basically. Next we have the Special Theory of Relativity, Mathematical Approach by Rahman. So basically, it's a mathematical approach to relativity. And it starts with pre-relativity and Galilean transformations, Magnuson-Morley experiment and the velocity of light, Lorentz transformations, mathematical property of Lorentz transformations, more mathematical properties of Lorentz transformations, geometric interpretation of space-time, relativistic addition and acceleration, four-dimensional worlds, mass in relativity, relativistic dynamics, photon in relativity, relativistic Lagrange and Hamiltonian, electrodynamics in relativity, and that's it basically. Oh, a relativistic mechanics of continua. So yeah, a mathematical introduction covers a lot of topics, and yeah, tries to do it geometrically and mathematically. But yeah, I think there's probably better books on the topic than this one, even though it's pretty nice. Next we have here this book, Thermodynamics, a thermodynamics book. I'm still not sure who wrote it. It's by Chu, I guess. So we have foundational concepts, basic postulates, and classical thermodynamics and their consequences, thermodynamics of a one-component system, extension of flow processes, thermodynamics of open systems, properties of ideal substances, direct and reversed heat engines, properties of real substances, thermodynamics of a multi-component systems, properties of an ideal solutions, thermodynamics of reacting systems, thermodynamics of special systems, and finally introduction of thermodynamics of irreversible processes. So I guess it's thermodynamics will geared more towards engineers, kind of. Don't think I ever read this book, so I really can't comment much on it. Next we have here Quantum Mechanics by Schwabel. So yeah, we start with historical and experimental foundations, the wave function and the Schrödinger equation. Then we have one-dimensional problems, uncertainty relation, angular momentum, the central potential, motion in the electromagnetic field, operators, matrices and state vectors, spin, addition of angular momenta, approximation methods for stationary states, relativistic corrections, several electrons atoms, the Zeeman effect and the Stark effects, molecules, time-dependent phenomena, the central potential 2, scattering theory, supersymmetric quantum theory, state and measurement in quantum mechanics. Yeah, so this guy is a physicist and writes things excellent for physicists, but I do think there's better books on the topic than this one. I think the book is kind of like very messy. There's not too much structure in this. So yeah. Here we have a book on irresistible integrals, symbolics, analysis, and experiments in the evaluation of integrals by Boros and Moll. So it's basically a book on difficult integrals and how to evaluate them. So we have factorials and binomial coefficients, the method of partial fractions, a simple or rational function, a review of power series, exponential and logarithm functions, trigonometric function, pi, a quartic integral, Euler's constant, Eulerian integrals, the gamma and beta functions, the Riemann-Zeta function, logarithmic integrals, the master formula, and appendix on the revolutionary WZ methods. So yeah, it's basically a book on all kinds of difficult integrals and how to do them. Yeah, it's not that I'm into it that much, but it can be pretty. The methods can be pretty at times. I guess definitely for somebody who is into like high school and into math or into like competition stuff, I guess it would be excellent for that.